has made some progress in defining a certain P-sheaf, which will help us a lot here. If we've done that, then of course we want to see how do the uncertainty relations look like. And it would be amazing, and we have some hope that this also has a lot to do with the logic within the topos, and this would be a nice thing. Usually uncertainty relations come from the geometry of Hilbert space, but it would be good to see, and well, this is really work which has to be done. We have some ideas how to do it. So uncertainty relations may also be related to the logical structure we have here. Then the question is what becomes in the superposition of states, how does it show up here? And where are the Hilbert spaces after all? All these are open problems, but of course the Hilbert spaces in some sense are there because we're talking about phenomenon algebras, and each phenomenon algebra is contained in some L of H. So all the Abelian subalgebras can be represented in Hilbert spaces also. So it's somehow implicit, but we want to make this more explicit. The long-term goals maybe are even more interesting, I hope so, but this is of course my further in the future is if we can do that, reformulate quantum theory within a topos, import all this structure there and see that these things work, and all the contextuality is there in a good and controlled way. Then we can also do this stuff for classical theory. This is quite straightforward, as I just see now. Then of course we can ask, is there axiomatization from that? Is there something we can abstract from? Can we say, well, if we have a topos and have this and that extra structure on the topos, and this can be called a physical theory? Maybe. And if we can do that, then we can try to generalize. We can say, well, take this topos, take this and that structure on that, and this is the physical theory. And it may, after all, be useful for quantum cosmology, quantum gravity. This is, of course, a vague hope by now, but what we're trying is really a new formulation, a new language, which is contextual, which is, well, Chris calls us neo-realist. I have a question, what becomes of realism? We know that we cannot assign numbers to the physical quantities in any straightforward way. We do know that we cannot answer all the questions, does A lie in delta by yes or no? We do know this doesn't work, but we see that within the topos, and this is topos P-sheaf, where a lot of things are known, we can see quite a lot of interesting structure. So, that's it.
Your maximum abelian algebras remind me of Basil's shadow manifolds.
There need not be a maximum abelian.
No, you got abelian algebras. I'm sorry. I'm sort of immediately not going as far as possible. But your abelian algebras remind me of Basil's shadow manifolds.
Of course, this is always what physicists wanted if they have a set of commuting operators, maybe maximally commuting, then you have no problems whatsoever. You can assign values, you can do all you would expect classically. The big problem that I see is that usually there's no control what is going on relating the context. Yeah.
But are you relating the context to some physical situation? Yeah, but he's not doing that here, is he?
No, yeah, this is a formalism, but I mean the physicists would come up and picking your algebra.
Yeah.
And you might pick up the algebra according to your experiment.
Exactly, yes. Specifying what R is would amount to looking at a certain physical system, and yeah, well, it's a shame we should have done this by now, but we'll surely do this soon. We were preparing the paper, and we'll consider some simple system, spin system or whatever, where we have probably finite dimensional Hilbert space, and things are really nice and simple to show what's going on there. specifying R means specify the observable algebra of the physical system, means specifying the physical system. So
I was die phenomenon. The R was the big algebra.
yeah, the big, yeah, specifying R, yes, this is the big algebra,
Yes,
the
the big
non-commutative
algebra,
one, yeah.
And then you look at abelian subalgebras.
Subalgebras.
All abelian subalgebras, yes.
Because these have a spectrum and
Yeah.
these.
I should say one thing which didn't really show up, but which
Yeah.
is, well, it's mainly technical. We want to exclude the, for technical reasons, it has to do with the negation operation. We want to exclude the trivial abelian subalgebra COI.
Yeah.
This is only a technical.
But you can relate the context by just taking the algebra generated by it, and that is a non-commutative intersection. That's exactly the non-commutative picture. And your picture is the commutative shadow of that picture.
That's right.
Yes.